Start.
Hello, sir. For the course ECE4003 Embedded System Design, our J component title is Home Automation and Security System. Myself, D. Pramod Satya, and my teammates are Inuganty, Venkata, Vineeth, and Vanamali Dheeraj. I thank you, sir, for giving us this opportunity. Now, moving on to the requirement of the project. Functionality. The main objective or requirement of the project is to control the home appliances remotely and ensuring security. User interface. The data of sensors can be viewed, analyzed, and visualized. Performance. Lights and fans can be controlled automatically, can get information about room temperature, detection of light using LDR, and controlling can conserve electricity is one of the functional requirement. The cost will be, the selling cost is less than $15. Physical weight. It needs a smart device which can access internet. Power consumption. The device should always be on power. Now moving on to the specifications. A specification of the home security system would include several components. Data received from the input device, more specifically captured by the sensors, predicting any harm before it happens, like fire accidents, operations that must be performed to satisfy customer requests. Fire accidents can be prevented. Moving on to the architecture, we use Arduino Uno, which means the microcontroller used is Atmega 328. Here you can see the flow chart of how the project moves. We have used all the sensors incorporated. The architecture, so the microcontroller we are using is Atmega 328, as I mentioned before. Now moving on to the components. So we are using Tinkercad for simulating our project. So the components which we need in the Tinkercad are Arduino Uno, motion sensor, which is a PIR sensor, temperature sensor, TMP36, photoresistor, LDR sensor, resistors and multimeters, breadboard, LEDs, bulbs, switches, servo motor, Ethernet cable, ThinkSpeak. ThinkSpeak is a IoT module and the relay module. Now moving on to the system integration. System integration is the process of integrating all the physical and virtual components of an organization system. Physical components consist of hardware used for the project like computer, application to interact, and keypad and LCD interface is integrated. We use Tinkercad for online simulation, as I mentioned before. Correction of errors and bugs will be done effectively. So these are the overview. These are the screenshots for the kitchen and the main room.
Start.
Yeah, so we are on Tinkercad now. So as you can see, we have a servo motor representing as a door, and a fan and a sprinkler represented as DC motors, and we have a LCD, and we have temperature sensor and a PIR sensor. All these are incorporated into Arduino. Now moving on to the kitchen. So this is the kitchen. Here also we are representing sprinkler, fan, and an exhaust using DC motors. We have a buzzer. If there is any indication, the buzzer will be on, and we have a LCD over here too. Now the working of kitchen will be explained more by Vineeth.
Hello, I'm Vineeth, and now I'll explain about the working of the kitchen. So as we see, we have started the simulation, and right now everything is. And right now, if you like vary the temperature, if we decrease the temperature is around 1 degrees Celsius. So the exhaust will be on, and the air quality is around 428 ppm. And now if we introduce smoke there, we can see that the exhaust is on, and so is the fan to remove the smoke. So if we increase the temperature, we can see that the temperature is now at 49 around 50 degrees Celsius. So the fan will be on, and so will be the exhaust. So if we increase the temperature more than 75 degrees, so again, if we introduce the smoke, we can see that the fan for the DC motor is actually turning on, and also so is the exhaust. But if we take the smoke away from the sensor, we can see that the exhaust will be turned off. Yeah, as you see, the exhaust is turned off. And right now, if we vary the temperature for more than 75 degrees Celsius, uh, our system will detect fire. So it will make sure that the fan is on. And so the LED, as you see, is turned on and the buzzer will be turned on. So the other room will be explained by Dheeraj. Start.
As we can see, this is the main room, and we've started the simulation. As like similar to the previous room, if the PIR sensor detects human motion, then the servo motor will turn 90 degrees, which is it already has. And if it doesn't detect any motion, then the door will again turn back to its normal position. And now coming back to the code, the first few lines are for the initiation of the Wi-Fi module, which will be used to communicate the data of the temperature sensor to the ThinkSpeak server. And these are the first few. We are using a simulator Wi-Fi. Our network system does not have a password. We are using ThinkSpeak server. This is the key which we can see in the ThinkSpeak server when we use it. We are initiating the Wi-Fi module. Then we are connecting the liquid crystal, and we are connecting different appliances like the fan, exhaust, sprinkler, LED sensor, and etc. to different pins of the Arduino. The byte degree is used to show the temperature data on the LCD. We are setting up all of these, as we can see. And for the first part, we are sending the temperature data to the ThinkSpeak server so that the people can monitor. And if there is a fire in the house without the user knowing, then the user can see this, and then they can immediately call the fire office and things like that. And coming to this, we are sending the data, then we are waiting for some time, and then we are taking in the data of the sensors. And if the temperature is greater than 22 degrees and it is less than 50 degrees, the fan will be switched on. And if the temperature is greater than 75 degrees, the sprinkler and the LED will be on, which suggests a fire. Otherwise, all of them are off. If the PIR sensor detects motion, it will open the door for the person, because this is an inside room, and it is an automated room. And this is the temperature. This is the LCD showing the data of the temperature. And now we'll be moving on to the ThinkSpeak server. As we can see that the data transmitted from the room is in the ThinkSpeak server, and here is the API key of the server, which is the same thing that we've used here and here. And coming back to the public view, we can see that we varied the temperature in the morning. The temperature was 24, then it went to a low of 10 degrees, and then it went to a high, and then it crossed 50 degrees, which does imply fire. And if the user does see this information, then he'll call the fire department if he's not present at the home. All about the ThinkSpeak server, and this is our project. Thank you.